volume of our solid and for its total surface area, we are going to need the area of this base. Okay, so we're going to draw a little picture of our hexagon. It's a hexagon, right? Yeah. So remember that prisms are named for their bases. So if this is a hexagonal prism, it's got a base that is a hexagon. Okay, this is supposed to be a regular hexagon, but you can see by my art, it's not going to look like one. We're just going to know that these sides are all congruent and the interior angles are all congruent. Okay, we know that all of the sides are 9 feet. Okay, so boop, boop, boop. If this whole thing is 9 feet, what is this little piece? Yeah.
They're yellow. They're on the right side.
4.5. Oh, shoot. This little piece is 4.5. Okay, and then we also know that this is a 6-sided figure. So how could I find this central angle? Remember, it's 360 if I spin around in the middle. Okay, and I'm going to chop that up into 1, 2, 3, 4, 5, 6 equal chunks. So I take my 360, divide that by 6, and what do I get for that angle measure? Yeah, it's 60 degrees in there. That's your central angle. So if I make this triangle, what is the measure of that little baby angle in there?
30.
30. Okay, we haven't forgotten everything. We're on it. Ain't no stopping us now. You guys see that we have a 30, 60, 90 right triangle down there? Okay. So what I want to know is this apothem, because I need the apothem to find the area of that hexagon, right? So what is my apothem compared to my short side? 4.5 root 3. So write that in nice and little and tiny. 4.5 root 3. That's my A. Okay, my side length is 9 feet. And how many sides do I have? 1, 2, 3, 4, 5, 6, because it's a hexagon. Okay, that's all of the information that I need to find my hexagonal base. So my base, I'm using a capital B because it's an area. It's 6 sides times 1/2 times my apothem, which is 4.5 root 3. Times my side length, which is 9. Let's leave the root 3 in there for now. So for now, let's multiply the 6, the 1/2, the 4.5, and the 9, and keep the root 3. So 3.
Oh, with the root 3 is
2.5. I'm getting 121.5 root 3. Is that what you guys are getting?
Yeah.
Okay. So my base area is 121.5 root 3. Okay, you guys want to do volume first?
That's what we were doing.
We just done the base.
We found the base. We need the base for the volume and for the surface area. Let's do volume first. So the volume is my base times my height. And this is my height of 12. So volume equals my 121.5 root 3. Sorry, I forgot the root 3. Root 3 times my 12 feet high.
We've done this before.
I know. It should feel like review. We just haven't done it for this figure. We've done all of these pieces before, but we haven't put them together for this figure. I'm sorry, should I have done something completely different and made it really hard?
No.
Okay.
2, 5, 4, 3.
Okay, so I'm going to multiply that by 12, and I get, oh my gosh, 1458 root 3, and it says that I can round to the nearest hundredth.
So 25.32.
So I got, 2525.33. And that is cubic feet. Feet cubed. Feet cubed. That's the volume. Okay. Let's talk about the surface area. So how many bases does this figure have?
2.
Yeah. So my surface area is going to be 2 hexagons plus, you see that I have 6 of these rectangles?
Yes.
Okay, thank you, Coach. 6 lateral faces that are rectangles. Everybody happy with that? Okay, so that equals 2 times, what was that base? 121.5 root 3. 121.5 root 3 plus 6.
And 2 of those.
And you see that this is 9, and my other dimension is 12. So it'll be 9 by 12
And
rectangles.
the 2 there, so wouldn't you have to add them?
Did I mess up?
No.
Okay, is everybody happy with that? We can just put that whole thing in the calculator.
1,068. Wait, 29. I'll say it again.
When you put in the root 3, make sure you arrow out of the root 3 before you add the 6. Okay, so did you say,
1068.
yeah, 1068.89. And this is square feet because it's an area, surface area. Okay, any questions? All right. So we're going to start with the base again because we need the base area for both of our formulas. So let's draw the base as a pentagonal prism. Okay, we're going to assume that this is a regular pentagon. Otherwise, we don't have enough information to do this problem. I like to do dots and then try my best to make the distance between them the same amount. It doesn't have to be perfect, just as long as you know that it's supposed to be regular. That was pretty good. I've done worse. Okay, so we need the central angle. Ew.
Wow.
We need this angle, right? So this time I'm taking my 360 and dividing it by how many chunks? 1, 2, 3, 4, 5 chunks. So that angle is 72. Thank you very much. Okay. So when I make my little apothem triangle down here, what is this little baby angle? It should be half of 72, which is 36 degrees. Okay, so this one we're going to have to do some trig because we don't have a special right triangle. Okay. What? Oh, okay. We're fine. We're fine. Okay, so they're telling us that this hypotenuse is 6. Right?
Sure.
Okay, and what we want is the apothem, which happens to be the adjacent side. We'll call that A.
3.
It's not 3. Okay, we're going to have to use trig. So do you see that we have the adjacent and the hypotenuse?
Yes.
So if we're thinking about SOHCAHTOA, which of our ratios uses the adjacent and the hypotenuse? Yeah, we're going to use the cosine. So the cosine of 36 degrees equals our adjacent / apothem over 6. What?
Is depth another word for height?
Yeah, it just depends on how you have your figure rotated.
Okay.
Yeah. And it kind of depends on the kind of, sometimes with furniture, instead of using length times width times height, they'll use depth instead of one of those other dimensions. But it can be one of those 3. Okay, so we want to find the apothem. So our apothem is 6 times our cosine of 36, because I have to multiply both sides by 6. So let's put that in the calculator. Make sure that you are on degrees and not radians. Here, I'll do mine on here. All right, so go to mode. Make sure that you're in degrees. And then we want 6 times the cosine of 36 degrees. I'm getting 4.85 for my apothem. Okay. My side length is kind of gross at 7.05. That's S. And my N is, how many sides have I got? 5. So my base area my 5 sides times 1/2 times my apothem, which is 4.85, times my side length of 7.05. And I'm going to do the calculator for that because I have no idea what that is. 5 times 0.5 times 4.85 times 7.05. I'm getting 85.48. Feet squared. Is that what you guys got? Okay, perfect. Okay. I can wait. I'm not erasing, I promise. So our volume is going to be our area base times the height. and the height is 9. Oh, I meant to write equals h. I wrote 9 equals 9. Awesome. Okay, so that is 85.48 times 9. So I just have mine saved on my calculator, so I can just do times 9. And I'm getting 769.33. 85.48 times 9. Okay, so if you use the rounded one, you should get 0.32. We'll use the rounded one. That's what you got, right?
Yeah.
769.32. 769.32. And that is feet cubed. Cubic feet.
And then I see.
Now we have to find the surface area. So how many pentagonal bases do we have? Correct. So we have 2 pentagonal bases plus how many rectangles sides? 5 rectangular sides. Okay, we already have the pentagonal base, and it looks like these rectangles are 9 by 7.05. Everybody happy with that? So that equals 2 times our 85.48 plus 5 times, 7.05 times 9. I'm going to put that in my calculator. I'm getting 488.21. Good quality control, thank you very much. If it's surface area, what would that be? Good, square feet.